Hello everyone, my name is Han Chao. I come from School of Information Engineering, Zhengzhou University. Today I'm going to introduce my paper which named Chinese Grammatical Errors Diagnosis System based on BERT at NLPTEA 2020 CGED shared task. I will introduce my paper in 5 parts. Section 1 will describe the introduction about CGED shared task. Section 2, I will show the challenge we face now in this task. Section 3 will introduce the hybrid system that we proposed. Section 4, I will show the experiment results. Section 5, I will conclude this paper and discuss our future work. The goal of CGED's shared task is to develop NLP techniques to automatically diagnose grammatical errors in Chinese sentences written by L2 learners. Here is an example about error sentence. What we should do is to find the error's type and position, and for the error types of selection and missing, recommended corrections are required. In this sentence, the selection error 未成年年 and 害处 is not fit the context. The better expression should be 未成年人 and 伤害. Next, I will introduce the challenge we faced now in this task. First challenge is variable text length. The maximum length of this task is 3,326 characters, and the average length of text is 46 characters. Second challenge is uncertain content and flexible theme. The third challenge is position nesting. The fourth challenge is low resource learning. And the last challenge is linguistic knowledge. Cause grammatical errors involve many linguistic problems, such as the confusion of characters, the collocation of words, and the analysis of sentence components, and the analysis of sentence semantics. Next, I will briefly introduce the hybrid system that we proposed. This paper proposes a hybrid system that utilizes both detection and correction stages. Detection stage is a sequential labeling model based on BILSTM and BERT contextual word representation. The correction stage is a hybrid model based on the n-gram and sequence-to-sequence model. In the detection stage construction, there are 3 layers in this stage. The first one is BERT embedding layer. In this layer, we can change the sequence of a character x1 to xn to token embedding, sentence embedding, and transformer position embedding. In the second layer, encoding layer, the bidirectional LSTM network can obtain the forward and backward hidden states by reading the sequence from left to right and reading the sequence information from right to left. Decoding layer. In this layer, the decoding layer is based on CRF with attention mechanism. CRF uses transition features to constrain the output sequence and output the final predicted label sequence. In the correction stage construction, there are 2 models in this stage. First one is n-gram model. We extracted 400 and 490 3-gram combinations from 20,000 correct sentences through the NLTK tool. If the previous word and the next word in the arrow position are the same as the beginning and the end of the treble, the middle word will be the recommended word. Then the model will use the frequency of 3-gram appearance as the answer score, sorting according to the score and get the best answer. The second model is a sequence-to-sequence model. We treat this model as a rewriting model. We extracted 4 features from sentences with grammatical errors: car, word, part of speech information, and dependency syntax information. Then we treated the training set and the testing set. In this article is CGED train that integrates 2016 to 2018, and the valid set is the CGED 2018 test set after deleting 114 units without control. 21,937 units are left for training. The performance of the 3 submissions is shown as follows. Our result shows that the system BERT BILS TM-CRF plus correction model performs best among many models. This is because BERT encodes sentence effectively extracting dynamic word vector features of sentence. We also found out that our result didn't perform well in FPR because the CGED task belongs to the cost unequal experiment. We should try to increase the cost of marking the sentence with non-error type as error in the experiment instead of treating the cost as the same. From our result, we can draw a conclusion that pre-trained models such as BERT can effectively extract the dynamic word vector features of sentence. Comparing the effects of embedding different pre-trained word vectors on the recognition effect and how to add a large amount of external knowledge to the recognition model to improve performance are issues worth exploring in our future work. That's all. Thanks for your watching.